Okay, so we're going to look at operations with complex numbers. Every number, the complex number is in the form a plus bi. Okay, and so if we work with and every number we work with can be put into that form. And so a is our real part, bi is the imaginary part. So if you're working with just a real number like the number 2, you can write that as a complex number by writing 2 plus 0i, right? Or if you're just working with the number I, that would be 0 plus 1 times I. So every number can be written in the form a plus bi. And so we see on part A, part B, part C here, we have an I squared, or I to the 32nd power, or negative I to the 131st power. Well, that's not in that form a plus bi. And so the first thing you want to know is if I ever has an exponent, you can always get rid of that exponent. And I want to talk about how to get rid of that first of all. And to do that, we need to look at, well, where did I originally come from? And it came from the problem trying to find the solution. What squared equals negative 1? And if we took the square root of both sides and we got the square root of negative 1, and with our prior history that didn't make any sense, so we had to define I as the square root of negative 1. But don't forget, it's the solution to this problem. So what's I squared? Negative 1. And so that's the key to getting rid of exponents with I. So I squared equals negative 1. You want to remember that. And so from that, you can find I to any power. So first of all, anything to the power of 0 is 1. I to the first power is I. We just said I to the second power is negative 1. So if I want I to the third power, well, what does it mean to be to the third power? That means I squared times I, right? So I cubed just means a product of 3 i's. And I already know what I squared is. So I could substitute a negative 1 for I squared. So it's negative 1 times I. And I end up with negative I as an answer. If I want I to the fourth, well, what would that be? 1. How do you know? Yeah, it's I squared times I squared, and I squared is negative 1. So negative 1 times negative 1 equals 1. How about I to the fourth? Sorry, I just asked about that one. How about I to the fifth? Why is it negative I? Who said negative I? Chase? Why did you say negative I? Why is it I? Good. So I to the fifth is I to the fourth times I. And we know I to the fourth is 1, so that's 1 times I, so we get I as an answer. But I to the sixth. Hopefully you're starting to see a pattern. That's what we're looking for here, okay? And we're looking for patterns until we keep doing this until we see a pattern, all right? What's this one going to be? This is going to be what? Negative I or negative 1? I heard both. Negative 1. Why? That's 1. So 1 times negative 1 equals negative 1. Okay. How about I to the 7? Negative I, how do you know? Starting to see a pattern? What's the pattern? 1, I, negative 1, negative I, and then starts over. 1, I, negative 1. So it's got to be the negative I, huh? We're thinking. Are you right, though? Yeah, you are right. The negative I. Okay? So if I say I to the 8th, you're going to say 1. I to the 9th, I to the 10th, I to the 11th, I to the 12th, 13, 14, 15. Now, so there's this pattern of 4 that just keeps going over and over and over again. And so if you have a pattern that repeats in cycles in 4s, how do you think about something like this? I to the 5,231 power. Yeah. Okay, so good. You're thinking if it's divisible by 4, it's going to be 1. If it's divisible by 2, well, if it's divisible by 4, it's divisible by 2. So maybe if it's not divisible by 4, but it is divisible by 2, then it'll be negative 1. So he's thinking about divisibility rules, which is great. That's what you want to think. There's an easier way than what you're thinking now. Okay, so look at the exponents. So here's what I want you to look at. So I want you to think about these numbers. Let's think about the exponent 3, the exponent 7. What would be the next one? So 3, 7. The next one would be, you're adding 4, right? What would it be? 11, 15, 19. How can we identify this group of numbers? What do they all have in common? They're not all prime, because 15's not, but almost all prime. They're all positive. That's not going to identify them. Huh? Okay, they're all odd numbers, but there's some odd numbers that aren't part of that. There's the other odd group, which is the 1, 5, 9, 13 group. So that's another odd group, right? So how do you know which odd group? So this is an odd number. How do I know which odd group it belongs to? Because it's going to be one or the other, huh? What's that? You count, but that takes a long time. There's another way. Okay, because they're, yeah, Chase, what do you say? So 15 though is not prime. So 15 would be what? So here's let me tell you guys. If you divide, think about this. What happens if I divide these numbers by 4? If I divide 3 by 4, what's my remainder? What's my remainder? You guys remember? Okay, let's go. Let's try 7. If you divide 7 by 4, what's your remainder? Okay, I get remainder 3. If I divide 11 by 4, what's my remainder? Remainder 3. If I divide 15 by 4, what's my remainder? 3. All these have a remainder of 3 after you divide them by 4. What remainder do these have? All of these have a remainder of 1 after you divide them by 4. So if I want to find out what group 5,231 belongs to, what am I going to do? Divide by 4, and I don't care what it divides. I care about what? The remainder, exactly. So 4 goes into 5 one time. 4 goes into 12 3 times. Bring down the 3. 4 goes into 3 0 times. Bring down the 1. 4 goes into 31 7 times. Subtract. And there's your remainder. Okay, so it belongs to this second group. Isn't that easier than counting all the way down? Yes. Okay, so can you guys tell me the answer? Negative I, because it belongs to the I cubed group. So in other words, whatever the remainder is, you can change. So here we go. If I have I to the 5,231, I could say that that's equal to I to the third power because that's the remainder when I divide that number by 4. Okay? And that's the key for us, all right? It's going to help us out a lot. So now let's take a look. Okay, this is easy. What's I squared? Don't forget that. That's the most important part here. Okay, I to the 32nd. Okay, so to get there, you divide 32 by 4, and you get a remainder of 0. So this is I to the power of 0, and anything to the power of 0 is, okay? Now, part C, we have negative times the I to the 131. So don't forget that there's a negative 1 out in front already. And then we have I to the 131. And that 131, if we divide that by 4, what happens? We get a remainder of 3. Okay, so we can change this problem. We can simplify it to negative 1 times I to the power of 3. And so it's an easier one to figure out. So if you just remember that I squared is negative 1, you can break this up. So I already have a negative 1. And then I got I squared times I. And I squared is negative 1. So negative 1 times negative 1 times I is going to be what? Just 1 I. Okay? Kind of weird, I know. We're not used to working with it. So, like I said, it has applications, but it doesn't have applications at what you're used to. It has applications in physics, it has applications in the flow of electricity, the flow of water, and very complicated problems. You need to know matrices and other kinds of things you haven't learned yet, but some of you may go into that field. Okay? All right. Right now, we're at the very basic level. We're just learning how to add and subtract and multiply and divide, okay? Yeah. You could. Okay. So here we go. Next example, okay? When you add or subtract complex numbers, okay? When you add or subtract complex numbers, it's just like adding and subtracting with variables. So if you think of I as just the variable x or y, all the rules that you learned before apply, and it'll feel just like any of those problems. So in this example here, it says to subtract, but I have a 2 out in front, so I'm going to multiply. I'm going to distribute by negative 2. I get 3 plus 4i, which I don't need parentheses around that. And then negative 2 times 5 gives me negative 10. And negative 2 times positive 2i would be negative 4i. And then you combine like terms. So the 3 and the negative 10, those are both real numbers. So I add them together, I get negative 7. And the 4i plus the negative 4i, bless you, they're both the imaginary. And so you add the coefficients and you get plus 0i. But we really don't need to put that part, so you just have negative 7. We could square a complex number. So 2 plus 3i is a complex number. We can square it just like you would. Now this one's going to be end a little different than you would with variables, but start like you would with variables. So this would be 2 plus 3i times 2 plus 3i. And just keep in mind, when you multiply 2, you should end up with another number just in the form a plus bi. Let's see if we can do that. So 2 times 2 is 4. 2 plus 3i. 3i times 2. Another 6i. 3i times 3i. Careful. Is 9i squared. Good. So this is no different than if we had an x there or a y there yet. And then we combine like terms. We got a 6i plus a 6i, which is 4 plus 12i plus 9i squared. And normally that's where you would stop. But we never stop there with complex numbers. What's wrong with this? I squared. We never leave I with an exponent because we always know how to simplify it. I squared is what? -1. And so this now becomes 4 plus 12i plus 9 times -1. And -9 plus 4, we can add those together and get -5 plus 12i. And so notice it's in that form a plus bi again. Okay, and you can always reduce it down to that form. You with me? Okay. So why don't you try f? We got two complex numbers again. Try multiplying those complex numbers together. Something magical happens here. What happened? The real number, right? So you multiply two complex numbers together that both have imaginary parts, but all the imaginary stuff goes away, you get a real number. And because 3 times 3 is 9, 3 times -2i is -6i. 2i times 3 is +6i. And 2i times -2i is what? -4i squared. And so it's -6i plus 6i is 0. And we end up with 9 minus 4i squared. But I squared is -1. So this is -4 times -1. So this really is 9 plus 4, which is 13. Okay. Now, if I give you a complex number, you can always give me another complex number that would multiply with mine to make a real number. And it's important that you can be able to come up with those sometimes. So if I say my complex number is, I'll start easy, 2i. Give me another complex number that you'd multiply with 2i to make it a real number. Your choice. What's that? 2i, let's try it. So if I multiply 2i times 2i, I get 4i squared, and I squared is -1, so that ends up being -4, and it worked. Good. Okay, let me make it harder on you. What if I say 1 plus I? Can you give me something to multiply with that? 1 minus I? I? Okay, let's try I first. So if I multiply this with I, 1 times I is I, and I times I is I squared. And I end up with I minus 1. Didn't work. Try it again. 1 plus I. What can we multiply 1 plus I by to make it a real number? Huh? 1 minus I? That's what you said, right? Right. Okay. So 1 times 1 minus I plus I minus I squared. So we end up with 1 minus I squared, which is 1 minus negative 1, which is 2. It worked. Okay. Okay. What about, okay, last test question here. What if I have A plus BI? What would you multiply that by to get rid of the I? A minus BI would work. And we call these conjugates. Okay. So one of them, everything's kind of copied down, but one has a plus sign between them, one has a minus sign between them. And whenever you multiply conjugates together, it gets rid of the imaginary part. Okay. So why is that important? Well, when you're dividing, okay, and you come up with an answer, we need to rewrite this in a form A plus BI somehow. Okay? And you can't do that, like, you can't do that when there's an I in the denominator. And so we somehow need to change the way this works in order to, because we're dividing two complex numbers somehow. And the way we do that is we focus on the denominator and think, well, what can I multiply that by to get rid of the complex part, the imaginary part? What would it be? 2 plus 3i. You multiply those together, you get rid of the I. Now, whatever you multiply the bottom part by, you have to be consistent and multiply the top part by. And the top part will not get rid of the I, and that's fine. Or it may, but it probably most likely, or most of the time, will not. And so you just multiply it out. You got two products. You got to multiply the top part and the bottom part out. Go ahead and do that. Work ahead of me. See what you end up with. Now I have it in the form A plus BI. Now I'm okay if you guys stop here. That's where you're used to stopping, right? One fraction. But I want to show you now that the I is not in the denominator, we can write it in that form where A and B are real numbers and I is the only part that's not. And so that's how you divide complex numbers. Okay. I'm going to pause there, and I have some problems for you to work on, 62 to 75. If you have some individual questions, I'd love to help you out.